C++11 introduced move semantics, which provide a cheap way to transfer ownership of resources without performing a deep copy. However, there are situations where using std-move can actually hurt performance or is simply unnecessary. Let's break it down. When returning a local variable of the same type as the function's return type, and the variable is not a function parameter, the compiler can often apply copy elision. This means it constructs the object directly in its final location, skipping any copying or moving entirely. For example, let's create an object here by invoking our function and observe the output here on the right. We see that only one object was created because the constructor and destructor were called only once. So instead of creating an object here and copying or moving it to another object here, we see that only one object was created. Starting from C++17, copy elision is guaranteed in this case where we return a temporary object, and it is called unnamed return value optimization. However, all major compilers were doing this optimization a long time ago, prior to C++17. If the function returns a named variable, copy elision is not guaranteed by the standard, but all major compilers implement it. This is called named return value optimization. But here's the catch. If you use std-move in any of those situations, you prevent copy elision and return value optimization, and that can make your code slower. For example, if we add std-move here, now we will see in the output on the right that actually two objects are created instead of the returned object directly being created here. Clang and GCC will even warn you about this if you use the following flag. The second case where you should avoid std-move is when returning a function parameter. If you're returning a parameter passed by value, the compiler will automatically move it when possible. Adding std-move here doesn't help, it's just redundant. Let's show you an example. Here in the output we see that an object was created here for the parameter, and then it was moved to create the object in the main function. If we add std-move here, nothing will change. Clang and GCC also have a warning for that, which is Wredundant-move flag. By the way, you also don't want to use std-move here because the compiler also performs copy elision for the parameters when they are constructed from a temporary. C++20 improved this further. Now if you return an air value reference parameter, the compiler applies automatic move semantics without needing to call std-move. Let's copy this function, name it func3, and change the parameter to be an air value reference, and call it here in the main function. If we observe the output, we see that actually here a copy was created instead of a move. So prior to std20, we had to use std-move here. However, with C++20, this is done automatically for us. So let's remove the std-move and observe that no copy will be created. In C++23, It gets even smarter. Automatic move applies even when returning an air value reference as an air value reference, not just by value. This makes code cleaner and more efficient in advanced scenarios. Let's copy the previous function, change the return value to air value reference, and see what happens. If we invoke the function in the main, we will see a compiler error in the output. That's because prior to C++23, we are forced to use std-move here. However, starting with C++23, it's okay to omit the std-move. As we can see, no compiler error. So while std-move is a powerful tool, knowing when not to use it is just as important. I hope you learned something new today. If you found this helpful, don't forget to like and subscribe. Thanks for watching. See you next time.